Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all of you. So today we continue our lecture on chapter 1, which is matrix. Okay, so today we are learning about inverse of a matrix. So how we want to find the inverse of a matrix if you have a 2 by 2 matrix or 3 by 3 matrix, and then we discuss a little bit exercise regarding to the inverse of a matrix. So the identity matrix of order n. What is identity matrix of order n? An n by n matrix with ones downs the diagonal from upper left to lower right, and zeros as well is called the multiplicative identity matrix of order n. This one means that all the diagonals of the matrix is the value is 1, okay, and the rest is 0. Means that here diagonal here all the value is 1 and the rest is 0. Okay, so that one we call it as identity matrix. Okay, this is the example of the identity matrix. If identity matrix of order n, order 2, so 1 0 0 1, where the diagonal is 1 and the rest is 0. For identity with size 3 by 3, the diagonal also equal to 1 and the rest of the elements is 0. So that one is the example of identity matrix of order 2 and order 3. Note that here, if the matrix M times N, then A times identity of order N equal to A, and I of identity of order M times A also equal to A. Okay, any matrix times by identity matrix, so we can get that matrix. Okay, inverse of a matrix. An n times n matrix A is called invertible or non-singular. Okay, if there exists a matrix n by n, is for example matrix B, such that A times B equal to B times A equal to matrix identity, so that this matrix B equal to A inverse. Okay, so this one we call it as multiplicative inverse of matrix A. Otherwise, A is called singular or non-invertible. Means that here, if you have the multiplication between two matrix and then the answer is matrix identity, so that means here that matrix is times by its inverse. Okay, so you can get matrix identity. In this case, A times B equal to matrix identity, so that B is the A inverse, because matrix A times by A inverse is equal to matrix identity. Okay, next, what is the theorems of inverse of a matrix? The inverse of a matrix, if it exists, it is unique. Okay, if A and B are both invertible or non-singular, then A times B is invertible and AB inverse also equal to B inverse times by A inverse. If A is invertible matrix, then A inverse is also invertible, and A inverse also equal to matrix A. And then the last one, if matrix A is invertible matrix, then A transpose is also invertible, and A inverse transpose also equal to A transpose inverse. Doesn't matter whether you inverse first and then you transpose, or you transpose first and then you inverse. That one is equal. So this is the theorems for the inverse of a matrix. Okay, example 2. Let matrix A equal to 2, 3, 2, 2, and B equal to -1, 3 over 2, 1, and -1. Since A times B equal to B times A equal to matrix identity, therefore B is the inverse of a matrix A. Means that here B is A inverse. If you find the multiplication between matrix A and B, or matrix B times A, you can get matrix identity. So that B is the inverse of matrix A. Okay, next, finding inverse of a 2 by 2 matrix. How to find the inverse when you have 2 by 2 matrix? Okay, if matrix A equal to A, B, C, D, then we can find the inverse of a matrix, which is A inverse, equal to 1 divided by AD minus BC times by, this one we change the position between A and D, and then B and C we put F negative sign. Okay, and then your value here is also for determinant, and then determinant cannot be equal to 0. Okay, and this one we can put as the formula as A inverse equal to 1 divided by the determinant of matrix A times by adjoint of matrix A. Adjoint of matrix A also equal to cofactor of matrix A transpose. Okay, so now looks on the example. Let A equal to 1, 2, 3, 7. Find A inverse. So in order to find A inverse, we can find the determinants of matrix A first. Determinant of matrix A we can get from 1 times 7 minus 2 times 3. So 1 times 7 we can get 7. 2 times 3 we can get 6. Then 7 minus 6 we can get 1. So this one is the determinants of matrix A. So we know that the A inverse equal to 1 divided by determinant times by adjoint of matrix A. So therefore 1 divided by 1, which is the determinant, and then times by adjoint, we change the position between 1 and 7, and then -2 we put as sign negative, as -3 also. Therefore your final answer for A inverse equal to 7, -2, -3, 1. So that is the example 3. Okay, so now looks on the find the inverse of the matrix 3 by 3. Okay, so how to find the inverse of matrix 3 by 3? Also a same thing. A inverse times by A inverse equal to 1 divided by the determinant times by adjoint of matrix A, and then adjoint of a matrix A also equal to cofactor of matrix A transpose. So we need to find first what is the cofactor of the matrix A. Okay, cofactor of the matrix A we can find for each element here. First, we goes to the first row. So cofactor matrix element 1 1, which is for this value. Okay, so we know that here is the negative 1 1 plus 1, the power of 1 plus 1. 1 plus 1 come from first element, first column. And then if we put the adjoint here, we already reduce the first row and first column. So the rest is 6 to 0 negative 3. Therefore, we can get the cofactor 1 1. After we find this value, negative 1 the power of 2 here, we can get positive 1. 6 times by negative 3 minus 2 times 0. So you can get negative 18. Okay. And then next for C12. C12 is this value, which is negative 1 the power of 1 plus 2. So we can get negative 1 here. So we reduce for first row and then second column. So the rest value we can get 5 to 1 negative 3 here. 5 to 1 negative 3, also a same thing. 5 times by negative 3 times by 2 times 1. So we can get 17. And then the last one is for C13 here. Okay, C13. So this one for value 1 here. Reduce first row, third column. So you can get negative 1 the power of 1 over plus 3. So we can get 1 here. And the rest value is 5610. After we times 5 with 0. And then minus 1 times 6. We can get negative 6. So that one for cofactor for the first row. Next, we look on the cofactor for the second row here. For the second row, okay, cofactor for the second row here, 562, also a same thing here, since this one is second row, first column. So this one, so the rest value is negative 2, 1, 0, negative 3, and negative 1 the power of 3. We can get negative 1. Negative 2 times negative 3 minus 1 times 0. So we can get negative 6. Also a same thing for the C22, cofactor C22 here. So second row, second column. So negative 1 the power of 2 plus 2. We can get 4 because the power of even number. So the rest value is 3, 1, 1, negative 3. So 3, 1, 1, negative 3 here. So we know that 3 times by negative 3 minus 1 times 1. So therefore we can get negative 10. Also a same thing for C23, which is second row, third column. So negative 1 the power of 2 plus 5, which is odd number. So we can get negative 1. The rest value is 3, negative 2, 1, 0 here. Okay, after you simplify this one, 3 times 0, which is cross section here, minus negative 1 times 1, and then the final answer we can get negative 2. That one for the second row. And then for the last one, third row here, also same thing. C3 1. So we have the power of 4, so we can get positive 1. Also same thing here, we can get negative 2, 1, 6, 2. And then the final answer for C, 3, 1 is negative 10. For C, 3, 2 here, which is a third row, second column. So we have negative 1 the power of 5. So we can get negative 1 because the power of odd number. 3 times 2 minus 5 times 1, we can get negative 1. And the last one, a 3, C33, third row, third column. So negative 1 the power of 6. So even number. So we can get positive 1. 3 times 6 minus 5 times negative 2. So you can get 28. So we already know all the cofactor of element. Okay. So this one is all the cofactor of the element. But we want to find the inverse. So we must use adjoint. Okay, we know that adjoint of matrix A equal to cofactor of matrix A transpose. So we need transpose the cofactor. Therefore, we can get the adjoint of matrix A here. So now we already have adjoint. Next, we want to find the determinant because the formula of A inverse equal to 1 over determinant of matrix A times by adjoint of matrix A. So now, the determinant we can find by using this row. And then after calculate, we can get negative 94. After substitute in the formula of the 1, A inverse equal to 1 divided by determinant of matrix A times by adjoint of matrix A. Therefore, we can get this answer for the A inverse. So that is the answer for example 4. Okay, now we also can find the inverse of a matrix by using Gauss-Jordan elimination method. Okay, so before this, we are using adjoint method to find the inverse. So now we want to use Gauss-Jordan elimination method. So if we have a matrix A, so now we have a matrix A, given a matrix A, and then we want to find A inverse by using Gauss-Jordan elimination method. Make sure we must check the determinant is not equal to 0. If determinant is 0, then A inverse does not exist. Okay, write the augmented matrix in the form A and then matrix identity. Reduce this augmented matrix by using row echelon form. Okay, by using ERO, elementary row operation, to change the matrix identity that places on the right hand side goes to the left hand side. So after we change the matrix identity goes to the left hand side, then the right hand side is become a matrix B. This matrix B also equal to A inverse. Okay, then we can check whether your matrix inverse is correct or not, because we know that A times by A inverse should be equal to the matrix identity. Okay, so now looks on the example. If we want to find the inverse of a matrix A by using Gauss-Jordan elimination method. Okay, so first we need to using ERO, then we must set up in terms of augmented matrix. So this is augmented matrix, whereby this one is a matrix A and then this one is the matrix identity. So now we want to change the matrix identity goes to the left hand side. So if we want to change here, we must set up this one equal to 0, 0, 0, 0, 0, 0, and the rest is 1. Okay, so now we can use this formula. So we want to change this two value first become 0. Remember, if you want to change row 1, okay, if you want to change row 1, here must be plus row 1. Cannot be multiplication with any value. It must be plus row 1. And if you want to change row 2, here must be plus row 2. You only can modify on this part. Okay? Because we want to change the row 1 and row 2. So we cannot times with any value except 1 here. Okay. So now we want to change this 4 become 0 by using row 3. So in order to get here value 4 is 0. So row 3 is 2. So 2 times 2 equal to 4. Okay, 4, and then we can minus with the row 1. So we can put as negative 2R3 plus row 1. Negative 2R3 plus R1, we can get 0 here, whereby negative 2 R3 equal to 2 and then plus R1 equal to 4. So here equal to 0. So that's why we get this equation in order to find the value of row 1. Also same thing for row 3. After we set up this formula, and then we can get this value here. So all the row 1 become changes. Okay, all row 2 also changes. The row that not changes with row 3, because we only change row 1 and row 2. Okay, next we want to change this value become 0. So when we want to set up this value become 0, we can use row 2 here. Okay, so this one we can put as formula row 1 equal to negative 2 row 1 row 2 plus row 1. So we can get this matrix, which is row 1 is already changes. So now this upper parts is already equal to 0. Next, our aims to change all these three value become 0. So we use row 2 and row 3. Make sure when you want to change row 2 and row 3, here must be plus row 2, here must be plus row 3. Cannot be multiplication with any value except 1. Okay, and then we can get this matrix. Okay, so now this value we want to change to become 0. So we can get row 3 equal to negative row 2 plus row 3. And then the final answer is this matrix. The rest one, we want to change the diagonal become 1. So row 1 times by negative row 1, row 2 times by 2 row 2, and row 3 divided by 2. So the value here is become this matrix. Since all the left hand side become matrix identity, so on the right hand side becomes the inverse of matrix A. So therefore A inverse equal to negative 1, 2, 1, 5, negative 8, negative 6, negative 3, 5, 4. So that is the answer for example 5. Now looks on the example 6. Find the inverse of the following matrix using elementary row operations. Okay. Also, same thing. We need to write in terms of augmented matrix. For the right hand side is a matrix identity. So now this value is already 0. So we need to change -1 become 0. So we can use this with the row 1. So we want to change row 3. So here must be plus row 3. Okay. So we can get this value on the row 3. And then this one become 0. Okay, so row 3 becomes 0. We can get by produce a formula row 3 equal to -2 row 2 plus row 3. Okay, and then we can get 0, 0, -1, 1, -2, 1. Okay, next we want to change here become 0. Then we can get 1, 2, 0 here, and also on the right hand side also same thing for the second row. Next we want to change 2 become 0 here, so then we can get this matrix. The last one we want to change -1 become 1, so we can get this final answer. On the left hand side is already matrix identity. Then the right hand side is the inverse of matrix A, which is A inverse equal to 2, -4, 1, -1, 3, -1, -1, 2, and -1. So that is the answer for example 6. So now you can try the exercise 1.3 in your module. Okay, for exercise 1.3a, after you find the cofactor, you can get a 3, -2, -4, -3, 2, 5, 1, -1, -2. And then we must find the adjoint matrix A, which is cofactor transpose, and then find the determinant, which is 1. A inverse equal to 1 divided by determinant of matrix A times by adjoint of matrix A. Therefore, your final answer is a 3, -3, 1, -2, 2, -1, -4, 5, and -2. So that is the answer for exercise 1.3a. Then the answer for exercise 1.3b, also a same thing. You can get a cofactor of matrix A equal to 5, -9, -3, -1, -1, 2, -3, -4, -1. And then adjoint equal to cofactor of matrix A transpose. So you can get this matrix. And then we can find the determinant of matrix A equal to -7. So we already have the adjoint matrix A and then the determinant of matrix A. So then we can put in the formula of A inverse equal to 1 divided by determinant of matrix A times by adjoint of matrix A. Therefore, you can get the A inverse equal to -5/7, 1/7, 3/7, 9/7, 1/7, -4/7, 3/7, -2/7, and the last element is 1/7. So that is the answer for exercise 1.3b. Okay? And then that's all. Thank you.